Hi there, this is Peter Odens, the Eureka Product Manager. Just going to give you a quick run through of some of the 2D seismic capabilities of Eureka. So Eureka is a product on the Maptek workbench. It is a standalone product. It can also be used in conjunction with our other products like Vulkan or BlastLogic. Fire it up. I'll just use an existing project which is basically empty. So this is opening the SQL database backend that things are stored in. And Eureka is an exploration package at heart with a lot of geological modeling capabilities. And it's really designed to bring all your different data types together in a single place and then do some modeling or analysis, interpret analysis, or whatever you want to do. So in terms of 2D seismic or 3D seismic for that matter, you can go through your file import menu, or you can just come to Windows and actually grab the files you're interested in, the segwise, and drop them on the screen. And it'll ask you if you want to put it into a particular coordinate system. Everything in Eureka can be coordinated, and everything can be got into the same coordinate space, but I'll just leave it as is. And you can set resolution and things as you import them. This is good, especially for big 3D seismic. So you can load it, say, initially with low detail so you don't overwhelm your machine, and then come back and see how much resolution you want. But I know for this data set, high resolution's fine. Let's just bring it in. So it loads them up, whacks them in your geophysical container, and centers your data on the screen for you. So if I go and find that, here we are. So we've got a whole bunch of 2D seismic traces. And so, obviously we can just view these in context with other data, and we'll have a quick look at that later. But we can also zoom in on a particular profile or series of profiles and play with them individually. So let's say we pick, this one here. So you can see here I've got this Explorer. I can quickly turn everything off and just look at one. So the way Eureka can load this is actually like a 3D wiggle. So you can actually see this as the amplitude is a three-dimensional thing, but we can come into the seismic menu and quickly change that to just make it more like your standard flat seismic. Obviously the profile is still in true location. We can change the coloring to your grayscale or whatever you like to typically have it as, and you can come in and manually change the actual colors you like as well. You can also change the highlight level, so you can sort of saturate it a bit more. You can adjust the viewing of your colors and to what amplitude they're applied to, till you can start to see visually what you want to pick. So when you're happy with that, you have other visualization tools as well. Things like the bright spots. So just sort of show me maybe the top 5%, and it will just highlight just those and make everything else invisible. Let's bring everything back. So you can muck around with your transparency, and then other settings like, if you have to bring it in with a different coordinate system or from a different coordinate system, you can do that. You can preview the trace locations here to double check everything's in the right coordinate system. You can bring in your depth extent. By default, it's just bringing in the whole time extent, but you can change that. And this is especially useful for things like very large 3D seismic. So you only load the part you need. You can also change things like the actual time zero and the default level of the top of the trace to line things up. We also have abilities to change the velocity model. So if your data has come in 2D with a particular velocity, you can come in and basically match your, say, some drilling information or known intervals in one window against known horizons you've picked in the other window, and get it to calculate velocities based on the thicknesses and the the intervals you've selected, and that will be then saved as a velocity profile for that particular trace, so you can adjust it and get things into a depth sequence. Once you have it all located, then you can do some interpretation, and by that I mean you can come and do some CAD. So let's just say pick number 2, give it a color. It's pretty yellow, and because this is not just dumb flat data, we can actually get it to do some tracing for us. So I can pick an actual location here and it'll smartly track along that interval. It's looking at the height of the amplitude, if you like, or the wiggle. So as long as you pick on something that's sort of continuous, it will go and do some smart tracking. You can see here I've jumped it up there, but very quickly I can build up some CAD work. And so let's just cancel out of there. That's also in true location. So all this stuff is in 3D. So that CAD information then becomes something I can throw towards my modeling, and I can start building up a bunch of interpretations, which I can then, connect from section to section or interrogate with my drill holes or whatever else I want to do to start building up some interpretations and some modeling down the track. The other thing, I guess, with this is it's, being Eureka, like I said, it's about getting everything into it's relative to the other data you have. So we might have some, say, shuttle radar. I can drop that on the screen and load that up. Let's bring it all in. Why not? So bring in your drilling, bring in your radar, your topography from whatever information you've got, and get it all into some sort of relevant space. So you're not just dealing with things in isolation. And even to the extent we have a Mapbox link, so we can then bring in real-time downhole satellite imagery to further locate yourself in space. Let's just turn off the shuttles there for a sec, which is updating on the fly. So again, it's all about, and obviously you can drape that onto a topography surface once you've made one or brought one in. And so it's all about getting your data in the same sort of coordinate space as all your other data and doing your interp and then building it all up into a coherent geological model. 3D is similar. We use our block model structure today to interrogate volumes of space. Okay, that's probably enough as a quick introduction. Any questions, please feel free to get in touch with me and we can follow it up further. Thanks for your time.